In this lesson, we are looking at probability and odds. So we're going to start with some terminology. The probability is a mathematical way to measure the likelihood of an outcome occurring. Our formula for the probability looks like this. If we see a P with an E in parentheses there, that means the probability of, and then event E, whatever that happens to represent. And that equals the number of outcomes satisfying E over the number of possible outcomes in the sample space, which is S, okay? Or another way to look at this is the number of favorable outcomes, the ones that meet what we're looking for, over the total to choose from, okay? So favorable over total is really the way that I remember probability, okay? It is a ratio, or it's a fraction, and we do need to remember that it has to be from 0 to 1, okay? It could be 0. So if I'm talking about, if I'm talking about the numbers 1 through 10 and I randomly pick a number, what's the probability that that number will be a negative 17? Well, 0, because there are no negative 17s to choose from. It could also be a 1, which is kind of like a 100% probability if we think about percentages. And that would be something like if I'm picking from the numbers 1 through 10, what's the probability that I pick an integer? Well, all of those are integers, so 10 out of 10 would be favorable, 10 would be total, so probability would be 1, okay? But we can't have a probability that is outside the range from 0 to 1, okay? All right, looking at this example, we have a spinner. We have 8 equally sized spaces, so the likelihood of each one getting spun is the same. The first question says, what's the probability of spinning a 3? Well, we might say, oh, well, we want a 3, there are 8 to choose from, so it's 3 out of 8, but it's not. The 3 only represents one of the spaces, so the number of favorable outcomes would be 1, and then how many total are there? 8, okay? So our probability of spinning a 3 is 1/8, okay? And then for the next one, what's the probability of spinning a number less than 4? Well, if I want numbers less than 4, it could be this space, or this space. So the number of favorable outcomes we have here is 3. The total number of outcomes is still 8. There's 8 spaces to choose from. So our probability is 3/8. Okay? Now, both of those that we just did are what is called theoretical probability. That means just the likelihood based on what is present, okay? Or if we were to spin, that's what we should see is a probability. If we spin it 8 times, we should see that one of them is a 3. Now, in all likelihood, if we spin it 8 times, we might not get a 3 every time, okay? We know that probability doesn't always work exactly like it should in theory. So what we then look at is what's called empirical probability, okay? Empirical probability is based on the recorded results when the experiment is repeated. So, for example, I have a standard die numbered 1 through 6, and I roll it 50 times, okay? And I record the number in this chart here. So this is the top number showing. Okay, so this is our number, and this is kind of oops, that's not what I want. Frequency, okay? How many times does that number pop up? So of the 50 rolls, which all of these should add up to 50, and they do, okay, so of the 50 rolls, how many times did a 1 show up? And it was 7 times, okay? So the total here is 50. Okay, so that's what that chart is. Now, what is the empirical probability of rolling a 6? Whoops, hold on a second. And sorry, sometimes it screws up a little bit. There we go. Okay, so what's the empirical probability of rolling a 6? So I look at my 6, and the 6 happened 9 times out of a total of 50 rolls. So my empirical probability is 9 out of 50. If that can be reduced, I do want to reduce it, but that one cannot, so we leave it like that. Okay, what's the theoretical probability of rolling a 6? Well, theoretically, I have a 1 in 6 chance of rolling a 6, okay? So 1 in 6. And let's compare those. As fractions, it's a little tough to compare, but if we think about the decimals, if I actually divide 9 by 50, I get about 0.18 or 18%, okay? 18% of the time a 6 was rolled. And if I do 1 divided by 6, I actually get about 0.17 or 17%. So really, that's pretty close, okay? So the actual probability was really close to what we would expect, okay? Next question, what is the empirical probability of rolling a 4? Well, a 4 was only rolled 4 times. So that's a 4 out of 50, which we can reduce to 2 out of 25, okay? Or if we think about that number as a decimal, that comes out to be actually exactly 0.08, okay? Which really we should have about 17% like we did on the probability of rolling a 6, because they should be about equal likelihoods. But in this case, it doesn't really mean that we did something wrong, but we didn't get as many 4s as we expected, okay? So now if we think about this, what can we do differently to bring the empirical probability of rolling each number closer to its theoretical probability, okay? It's not that the die was weighted or anything like that, but the fact that we rolled it 50 times may not have been enough times to really show the true theoretical probability, okay? And there's actually a theorem that says the more times an experiment is repeated, the closer the empirical probability is to the theoretical, all right? And there's a nice chart about that in your book. But so really we could say if we had more repetitions, okay, like maybe we rolled it 500 times instead of just 50 times, we'll probably get a lot closer to that 17% for each of the numbers, okay? All right, odds, another term here. Odds is something that we hear. We know it has something to do with how likely something is to happen, okay? But the mathematical definition for the ratio is a little bit different than probability. And when we talk about odds, we talk about the odds in favor of something or the odds against something. So the odds in favor of event E happening is the ratio of favorable outcomes to unfavorable outcomes. So favorable outcomes is still the same numerator. How many ways can what we want to happen, okay? But then unfavorable outcomes means the rest. So the unfavorable would be the total number of outcomes minus the favorable outcomes. How many are left over? In my first example of the numbers from 1 to 10, if we're talking about how many ways can you pick a multiple of 3, well, there's 3, 6, 9, so there's 3 ways, and so the probability would be 3 out of 10, but the unfavorable outcomes would be 1, 2, 4, 5, 7, 8, 10, or the other 7 numbers. So the odds would be 3 to 7. And we'll do another example of that in a second here. The odds against is just switching the numerator and the denominator here. So it's the unfavorable over the favorable, okay? So just be careful with the terms there on which one they're asking. Okay, this example says the probability of an event is 3/11. What are the odds in favor and against the event? Okay, well, 3 over 11 then becomes my favorable, I'm going to abbreviate FAV here, okay, favorable and my total. Okay, I want, for the odds in favor, I want the favorable over the unfavorable. So the odds in favor, okay, are going to be 3, 2, and then if there are 11 total and 3 favorable, that means there are 8 left over for unfavorable. So 3 to 8, okay, or another way that you'll frequently see this written is 3 to 8 like this, okay? Either one of these are acceptable. This one is a little more common with odds because it's possible for that denominator to be a 1, and it looks funny if you write a fraction as 3 over 1 because you might think, hey, well, why don't you just reduce that to be 3? We really do need both numbers present, though, so if we write it with a colon in between there, we're saying 3 to 1, and each of those pieces is representing something because it's a ratio. Also, on that topic, well, here, let me do the other one. And then the odds against means I need to flip that upside down, okay? So against, or switch them in the case of the horizontal one. I'm going to have 8 to 3, okay? So the odds against is 8 to 3. If I wrote this as 8 over 3, that would be fine mathematically as well, but do not change that to 2 2/3. This is not just a fraction. This is not just a fraction, and we can say, oh, well, let's just make it into a mixed number. One, because mixed numbers are kind of gross, so don't do that. But also because it represents something different when you change it to a mixed number. It's no longer a ratio, okay? It's no longer a ratio. It's just a number, and we want a ratio. Okay, for this last example, it says that the House of Reps has 235 Republicans, 195 Democrats. One member is selected at random. What are the odds that he or she will be a Republican, okay? So favorable is going to be Republicans, which is 235, okay? 2, and then unfavorable would be the not Republicans, which in this case means Democrat, and so that is 193. So the odds are 235 to 193. In this case, we didn't really need the total, okay? We could add those together to get the total number of members of the House, but it's not necessary here. I didn't leave any information out here. There aren't any third-party candidates that are currently holding office in the U.S. House. So if there were, we would need to add that to the unfavorable. But really, this is the breakdown as it currently stands. So when you are doing problems involving probability or odds in favor or odds against, just be really careful about which one you want because they are closely related, and so pay attention to the terms.